Hello, welcome to 10.3, Parametric Equations and Calculus. Okay, Theorem 10.7 says parametric form of the derivative. If a smooth curve C is given by the equations x equals f of t and y equals g of t, then the slope of C at xy is dy dx is dy dt over dx dt, as long as dx dt is not 0. Our second derivative is going to be the derivative with respect to x of dy dx, which would be the derivative with respect to t of dy dx over dx dt. Again, as long as dx dt is not 0. And our third derivative with respect to x is ddx of the second derivative of this result, which would be the derivative with respect to t of the second derivative of y with respect to x over dx dt. Example 1 says find dy dx and the second derivative of y with respect to x, and find the slope and concavity if possible at the given value of the parameter. So we have x equals 2t, y equals 3t minus 1, and t equals 3. So our dx dt is going to be 2. Our dy dt is going to be 3. dy dx is going to be 3/2. Our second derivative of y with respect to x is going to be the derivative with respect to t of 3/2 over 2, which is 0 over 2, which is 0. So at t equals 3, the slope is 3/2. In fact, everywhere it's going to be 3/2. So that's because the set of equations is the equation of a line. No concavity, because the second derivative is 0. Part B, x equals 2 cosine theta. So dx d theta is going to be negative 2 sine theta. dy d theta, y is 2 sine theta, is going to be 2 cosine theta. dy dx is going to be 2 cosine theta over negative 2 sine theta, which becomes negative cotangent theta. Our second derivative of y with respect to x is going to be the derivative with respect to theta of cotangent theta, negative cotangent theta, over our dx d theta, which is going to be 2 times negative sine theta, or just say negative 2 sine theta. This is going to be cosecant squared theta over negative 2 sine theta. That's going to become negative 1/2 cosecant cubed theta. So at theta equals pi over 4, dy dx, the slope is going to be negative cotangent of pi over 4, which is negative 1. And our concavity, the second derivative of y with respect to x, is going to be negative 1/2 cotangent of pi over 4 cubed. Oh, sorry, it's cosecant. That's going to be negative 1/2 times square root of 2 cubed. That's going to become 2 times the square root of 2 over 2 negative, or negative square root of 2. That is less than 0, so it's concave down. My pen's getting dry. Okay, that'll do it for page 1. go to the next page. Feel free to pause. Uh-oh. There we go. So use a graphing utility to graph the curve represented by the parametric equations. Use a graphing utility to find dx dt, dy dt, and dy dx at the given value of the parameter. So you can do this on the T89. I think you can do it on the TI84 as well. You can ask for the derivative at certain points on a curve. Find an equation of the tangent line to the curve at the given value of the parameter. Finally, use a graphing utility to graph the curve and the tangent line. So in graphing this, we have x equals t minus 1, y equals 1 over t plus 1. So our curve looks like this. On the T89, you can use F5 derivative to get the values. And so t equals 1. X equals 1 minus 1, which is 0. And y equals 1 over 1 plus 1, which is 2. So we have 0, 2. Our dy dx, should say, our dy dt is going to be negative 1 at x equals 1, or t equals 1. Our dx dt is going to be 1 at t equals 1. So dy dx is going to be negative 1 over 1, which is negative 1 at t equals 1. So our slope here is negative 1. So y equals mx plus b. Y equals negative x plus 2. And it's going to be going like, say, negative x and probably should modify my curve a little bit because it goes through that point. Okay. That's that. Feel free to pause that and go on to example 3. It says find all points, if any, of horizontal and vertical tangency to the portion of the curve shown. X equals 2 theta, y equals 2 times 1 minus cosine theta. The curve looks something like this. It's going in that direction. So we have some tangency, horizontal tangency there. So for vertical tangency, dx d theta is going to be just 2, and that's never going to be 0. So there's no vertical tangents. For horizontal tangency, dy d theta is, that's going to be 2 times 1 is 2, derivative is 0. 2 times negative cosine, its derivative is going to be 2 sine theta. And that'll be 0. Let's say 2 sine theta equals 0. 0. When theta is 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, plus or minus n pi. So at the points, since x is 2 theta, points are going to be 0, 0, 2 pi, comma, if you put pi in here, cosine of pi is negative 1. 1 minus negative 1 is 2. 2 times 2 is 4. For 2 pi, 2 times 2 pi is 4 pi. Cosine of 2 pi is 1. 1 minus 1 is 0, so that's 0. Put in 3 pi. 2 times 3 pi is 6 pi. Cosine of 3 pi is negative 1. 1 minus negative 1 is 2. 2 times 2 is 4. Starting to see a pattern there. So it's going to be 2 times the quantity 2n minus 1 times pi, comma 4. That is, if it's 2 times an odd number, then you're going to get 4. Otherwise, it'll be 4n pi. You'll always get a 0. Okay, again, feel free to pause that. I'm going to go on to the next page. It says, determine the intervals on which the curve is concave downward or concave upward. So our dy dx is going to be dy dt over dx dt. dy dt is going to be 2t plus 3t squared over dx dt is 2t, so we get 1 plus 3t over 2. So our second derivative of y with respect to x is going to be the derivative with respect to t, of 1 plus 3t over 2 over 2t. And that's just going to be 3 halves over 2t, or 3 over 4t. Now this is concave up when our second derivative of y with respect to x is positive, so that's whenever t is positive. It's concave down when the second derivative of y with respect to x is negative, and that's where t is negative. Okay, Theorem 10.8, arc length in a parametric form. If a smooth curve, C, is given by x equals f of t, y equals g of t, such that C does not intersect itself on the interval from a to b, except possibly at the endpoints, then the arc length of C over the interval is given by s equals the integral from a to b of the square root of dx dt squared plus dy dt squared, which would be the same thing as dt, same thing as integral from a to b of the square root of f prime of t squared plus g prime of t squared dt. And we'll get to find our arc length now. So find the arc length of the curve on the given interval, x equals t squared plus 1, y equals 4t cubed plus 3 from negative 1 to 0. So our dx dt is 2t, and our dy dt is going to be 12t squared. So dx dt squared is going to be 4t squared, and dy dt squared is going to be 144t to the fourth power. So when we look at dx dt squared plus dy dt squared, we're going to have 4t squared plus 144t to the fourth. I'm getting kind of frustrated with my pens here. Here's another blue pen. Oh, that's better. So S, the arc length, is going to be from -1 to 0 of the square root of 4t squared plus 144t to the fourth dt. So S would be the integral from 0 to 1, or -1 to 0, excuse me, of the square root of, you could factor a 4t squared out of that. You'd have 1 plus 36t squared dt. So this would be the integral from -1 to 0 of 2t. I'm going to say -2t because we're from -1 to 0 of the square root of 1 plus 36t squared dt. So this could be your u, and your du would be 72t. So this becomes 1 plus 36t squared to the 3/2 power over 3/2 times 36. Why 36? Because if you divide by 72, 2 and 72 reduced to be 36. Can't forget about the negative though. We're going to evaluate this from -1 to 0. So this is going to be the negative of 1 plus 36t squared to the 3/2 over 54. That's going to be the negative of 1 to the 3/2 over 54 minus 37 to the 3/2 over 54. Which will be the negative of -4.149. So it's a 4.149. Okay. I'm going to go on to the last page. I've got a couple examples left. Example 6 is find the arc length of the curve on the interval from 0 to 2 pi. The circle with the circumference, we're trying to find the circle with circumference x equals a cosine theta, y equals a sine theta. I don't want red. dy d theta is a cosine theta, and dx d theta is going to be negative a sine theta. So S would be equal to the integral from 0 to 2 pi of the square root of negative a sine theta squared plus a cosine theta squared d theta. S is the integral from 0 to 2 pi, square root of a squared sine squared plus a squared cosine squared theta d theta. So it's going to be square root of a squared times sine squared theta plus cosine squared theta d theta, and of course this is just 1, that part. So S would be the integral from 0 to 2 pi of the square root of a squared d theta. So it's going to be integral from 0 to 2 pi of a d theta, which will become a theta from 0 to 2 pi which is a times 2 pi minus 0, or 2 pi times a, where a to be the radius. The last concept here, area of the surface of revolution. If a smooth curve C given by x equals f of t and y equals g of t does not cross itself on the interval from a to b, except possibly, I guess it's not giving this the exception this time, then the area as of the surface of revolution formed by revolving C about the coordinates axes is given by the following. Now this is capital S, so much like we saw earlier in, I think it was chapter 7, little s was arc length, capital S was surface area of revolution. S equals 2 pi, integral from a to b, of g of t times the square root of dx dt squared plus dy dt squared dt. That's if it goes about the x-axis. And s equals 2 pi from a to b of f of t, square root of dx dt squared plus dy dt squared dt, if it goes about the y-axis. So we have a little two-part problem here. We're going to find this on the area of the surface generated by revolving the curve about each axis. In the first case, x equals, it's x equals t, y equals 4 minus 2t. We're going to go about the x-axis and the y-axis. So right off, dx dt, derivative of t is just 1. dy dt is just going to be negative 2. This would be 2 pi times the integral from 0 to 2 of 4 minus 2t, that's our g of t, times the square root of 1 squared plus negative 2 squared dt. That's 2 pi times integral from 0 to 2 of 4 minus 2t times the square root of 5 dt. And that's going to be 2 times the square root of 5 times pi times 4t minus t squared from 0 to 2. That's 2 times the square root of 5 times pi times what? 4 times 2 is 8. 8 minus t squared, 2 squared is 4. 8 minus 4 is 4. So 4 minus, put 0 in there, you get 0. So I get 8 square root of 5 pi. And in the second case, we're going to about the y-axis, so it'll be the second formula. S would be equal to 2 pi integral from 0 to 2 of t times the square root of 1 squared plus negative 2 squared dt. That's going to be 2 pi integral from 0 to 2 t square root of 5 dt. That's just going to be 2 times the square root of 5 times pi times t squared over 2 from 0 to 2. So we have 2 times the square root of 5 times pi times 2 squared is 4, so it's 4 over 2 minus 0 over 2. So it's going to be 4 times the square root of 5 pi. Okay, and that'll do it for 10.3. So I will see you guys on Thursday. Send me your questions, and I will talk to you later. Bye.